All right, guys, in this video, we're going to go over factoring with kind of three different things. We're going to factor out a greatest common factor. We're going to factor something called the difference of two squares, which I call DOTS as an acronym. And then we'll end up finishing with factoring by grouping. All three are things that you constantly need to be checking for when you're factoring, no matter if it's a quadratic, a polynomial, like a trinomial, or a cubic function, quartic function, doesn't matter. Always be checking for these. So greatest common factor, you're looking for constants, which are numbers, or variables, or both, that all of your terms have in common. So like if we're looking at this first one, part A, we have two terms here. This is a cubic binomial, and I'm trying to figure out, can I take out anything from the 50 and the 18? And the number they have in common, that greatest common factor, is a 2. So I'm going to factor out 2. And then the way you do it with variables, right, is they both have m. This is m to the first power. You can factor out up to the lowest exponent. I'll repeat that. You can factor out with variables up to the lowest exponent. So I'm going to factor out m to the first power. Okay? When you factor out, factoring is really the same as dividing. So I'm going to take each of these terms separately, right, and divide them by the factor that I pulled out. So 50 divided by 2 is 25. And then m cubed divided by m, you can think of it like this, m cubed over m to the first power. If you guys remember your days in pre-algebra, you're going to subtract these exponents to get m squared. And then plus, all right? And then because m divided by m is just going to be a constant, we have 18 divided by 2 will give us plus 9. All right? Whenever you do this, always, if you want to make sure, you can always redistribute, right? Multiply the 2m that we pulled out by each of the terms. And if you are correct, when you do that, you should get what you started with. So you can always do that to check. Let's do that for B. So part B, I'm looking first at the constants. I see 3, 18, and 81. So I'm going to factor out a 3. That's the greatest common factor. Sorry about that, too soon on the parentheses. And then when I look at my variables, I notice that the first term and the last term have x, the variable x, but the middle term doesn't. So because the middle term, 18y squared, does not have the variable x, I cannot take that out. And it looks like they all three have the variable y. And again, this is y to the first power. So I can factor out up to the lowest exponent, which is y to the first power. All right, so what's remaining when I divide? 3 divided by 3 is 1. There's x squared divided by, I didn't pull that out, so that's going to come with, be my first term there. And then y divided by y is 1, so I don't write a y. Plus 6 times 3 is 18. Y squared divided by y is y to the first power. Minus 81 divided by 3 is 27. We're going to copy down the x cubed because we didn't take out any x's. Y cubed divided by y to the first power is y squared, right? We subtract the exponents. All right, so that is going to be factoring out the greatest common factor. Okay, I told you another one we're going to do is factoring the difference of two squares. So I call this dots, right? The idea is this is the difference of two squares. All right, that's an acronym that I would recommend memorizing. And this is kind of the general formula for that. We have a squared minus b squared, so that's the difference of two perfect squares, is factored as a minus b times a plus b. Okay? Now again, this only works if both of your terms are perfect squares and you have subtraction between them. So look at part A. When I look at 121x squared, I need all of that to be able to take the square root of it. So in my brain, I'm thinking, what is the square root of this? Well, I know the square root of 121 is 11, and the square root of x squared is just going to be x, all right? Minus, do the same thing for the next one, 144a to the 6th power. The square root of 144 is 12, and then the square root of a to the 6th power is actually a cubed. All right, now that's not the only thing you have to write. You have to write another one where you copy those factors down, but we have addition in between. Again, you can distribute and FOIL this, and you should end up with the same thing we started with. The reason that we don't get a trinomial when you multiply these out is because the middle two terms, right, if I were to multiply the one that I put up here, this is a squared plus ab minus AB minus B squared, you'll see that the middle two terms end up becoming 0. So that's why when you look at these problems, they only have two terms, okay? All right, let's try part B. All right, so I'm doing the square root of 16 is 4. The square root of x to the 4th power is x squared minus the square root of 81 is 9. Don't forget to write it again. So 4x squared plus 9. Now this would be done, but if you notice this very first one is actually another difference of two squares. All right, so I'm going to keep going and factor that. The square root of 4 is 2. The square root of x squared is x. So that's 2x minus 3 and 2x plus 3. And then you bring down the 4x squared plus 9. Notice I did not factor the 4x squared plus 9. You cannot factor the sum of two squares. The sum of two squares is not a thing. So if you look at part C, kind of makes sense they put it there. This is not factorable because the sum of two squares is not a thing. So let's say SOTS is not a thing, right? The sum of two squares, not a thing. Okay, so that's factoring with the difference of two squares. Let's go to the last thing, factoring by grouping. This will be, we're going to start with looking at grouping with 4 terms, where you group the first two terms, and then you group the second 2 terms. All right, so the first two in this first example, I'm going to group x cubed and 7x squared, and then I'm going to group negative 9x minus 63. Notice when I put my parentheses there, I went ahead and that 9x has a negative in front, subtraction. So I grouped that with the second pieces. All right, so make sure you pull the sign where it's supposed to go. Okay, so if I'm only looking at the first 2 terms, right, just looking at these, I can factor out they both have the variable x up to the lowest exponent, which is 2. So I'm going to factor out x squared. All right, remember factoring is really dividing. X cubed divided by x squared is x. 7x squared divided by x squared is just going to leave me a 7. Notice I did not factor out a constant because the first term x cubed does not have a constant. Okay, so looking at the next two, I see negative 9x minus 63. So this one I can only factor out a number, and I'm going to factor out a 9. Now, just kind of a cheat code here, guys. Whatever the sign is in front of that third term, you should pull that sign out, because if you don't, then you're not going to be able to factor this correctly. But if you do pull that out, negative 9x divided by negative 9 is a positive x, and negative 63 divided by negative 9 is plus 7. And this should be the case, especially if I'm telling you we're factoring by grouping. You should expect to see that these are the same. If those are not the same, you cannot continue to factor by grouping. All right, so if we're doing a problem where I specifically state it's factored by grouping, if you don't see those in the parentheses are the same, then either you've made a mistake or this is not able to be factored by grouping. All right, so now here's how you continue. The stuff that's in front, the x squared and the minus 9, so what you pulled out of each group is going to make a term. So x squared minus 9 becomes a factor. And then you actually only bring down x plus 7 because they share the x plus 7. So just bring down one of them. Now, if I were to pause here, right, and distribute these two binomials, I would get what I started with, right? This cubic polynomial with 4 terms. But we can keep factoring. Hopefully you recognized that this is x squared minus 9 is the difference of 2 squares. So that's x minus 3 and x plus 3. And again, you'll get better as you do this at recognizing these special cases. So this right here is our fully factored form of that original polynomial. Again, they're not any different, just one is factored and one is not. Okay, let's do one more. So part B here, I'm going to group the first two and group the second two. So what can I pull out of 2ax minus ay? Cannot pull out 2 because the other one doesn't have a number in front. I cannot pull out x or y. They both don't share it, but they do both share an a. So when I pull that out, I get 2x minus y. Now in the second group, they both have constants. So I'm going to pull out a plus 2. Right? Remember to use that sign as like a cheat code. So plus 2. And then they both don't have x and y, but they both have c. So when I pull out that 2c, 4cx divided by 2c is going to be 2x. And then 2cy divided by 2c is minus y. Again, hopefully you're not surprised there. I'm expecting these to be the same in an example with factoring by grouping. Okay, so the A that I pulled out of the first group, the 2C that I pulled out of the second group, that's going to make one factor. And then they share 2x minus y. So you just bring down 1. And then it doesn't look like I can continue factoring any of this. So this is my fully factored version of part B. All right, so there's some homework questions, lots of homework questions. You can practice these different ways of factoring and come see me if you have any questions. Good luck.